a no wake zone or very slow movement of the boat. In the 6 to 12, this is the semi-planing mode, and this is the area that's bad for making waves. And then if you go faster than 12, depending on the boat, you're in the planing mode, and the amount of wake is much less. Look at the nature of the boat wakes. They're formed by two actions. First is the displacement wakes, boats plowing the water with the bow. And the second one is planing or transverse waves created by the stern and the propellers. For classical wakes, I emphasize the word classical, once formed, wakes decay as the distance from the sail line as the negative 1/3 power. Wakes decrease by half for every 8-fold increase in distance from the sail line. This little graph shows an example of a 4-foot wake as it decays over the distance. So you can see at 140 feet, it's down to 2 feet, and then out at 1,280 feet, it's down to 1 foot. Now, just yesterday, I got a new study that I have sent to Laura, and I highly recommend this study. Maybe she'll send it to everybody. It's done by a water environmental consultants of Mount Pleasant, South Carolina, and it was done for some lake associations in Georgia. And it provided data that I've been trying to get for 2 years, and that is how do the wakes from a wake boat actually decay? And that's what this chart shows. Now I'm going to, those numbers are hard to read, so let's look at it in table form. Here's the wake heights on the left for 5, 4, 3, and 2 foot wakes. And let's focus on the 4 foot ones for the classical and the empirical. So the classical, as I showed on the previous chart, it runs out to 1,280 feet to get a 1 foot height wake. For the empirical, the actual measured wave heights from a wake boat, they are considerably less. So the 1 foot height shows up at about 410 feet, or without splitting hairs here, the height at 500 feet is 0.96, so we'll just round that off to 1. So you can see that the actual wave height is a little different than the classical one. But nevertheless, the wakes produced by these boats are still very significant and of some considerable concern. We've selected 500 feet as the standoff distance for large wake activities. And the current Maine law of 200 feet for wakes starting at about 2 feet is reasonable. That works okay. But it's these large ones that are not okay. We are especially concerned about wake boats. These boats are designed to make very large wakes, 4 feet or more. They're used to support the relatively new sport of wake surfing. Although they are very expensive, they are proliferating in our area. We've had many complaints about the wakes these boats create. And when you get 3 to 5 of these boats operating in the same area at the same time, you get a violent, turbulent wave action on the lake. And the waves can actually be 2 times as high than a standalone wave. As you may know, waves add and subtract, and when these things are, these boats are circling or whatever they're doing, they can create a very violent, turbulent atmosphere with waves. Now, we're not concerned about the wake boats per se, but how and where they're used. The wake boats are marvels of marine engineering. Most of them have computer-controlled features where you press a button for what you want to do. If you want to water ski, you press the water ski button and the boat configures itself to water ski. It has no ballast and it creates very little wake. But if you want to do wake surfing, then you press that button and the boat takes on a lot of ballast, configures its plates and so on. These wake boats have the capability to be operated in ways and locations that can cause damage, injury, and erosion. Now here's an example. These images were taken by a trail camera set up to view loons on the nest in one of our floating loon platforms. The image shows a large wake created by a wake boat about 250 feet to the left, propagating towards the shoreline on the right. The platform was anchored on a small island in front of the camera, and the wakes appear to be about 2 feet high. The consequences of the loon platform tilting, as you see, could be that the egg may roll out of the nest into the water. Another possibility is that the wake could just wash right through the nest and flush the egg right out into the water. Wake boats have many different sizes and shapes, but generally they're pretty big, 22 to 26 feet long, 8.5 feet wide, way up to 10,000 pounds, holds a lot of people. They can take a lot of ballast, 5,000, some are 6,000 pounds. They have very big engines and they cost a lot of money, but that doesn't seem to deter those who own them. Here's a typical wake boat. This is a Malibu 22, and you can see the little scale there that it's created a 4.2 foot wake. Here's the new kid on the block. This is an all electric wake boat, a Super Aeronautique GS22E. This boat costs $300,000, totally computer controlled, and I expect that once the other manufacturers start to build this type of boat, the price will come down considerably. These electric powered boats are probably the future of a lot of boating activities. And if that wasn't enough, here's the granddaddy of them. This is a GigaWave electric boat, an all-electric boat. It has two 300 horsepower engines in it, and it creates an 8-foot wake. And you can see this surfer surfing the curl just like on the ocean. Hopefully we never get these babies in the Northeast. So what should we do about addressing large wakes? To create some guidelines concerning these wakes on our lake, educate the boaters. We have signs at the public launch sites, instructions by the marina staff. We use the lake patrol to encourage wake surfing and wakeboarding boaters, and anyone that create large wakes to abide by our guidelines. We publish newsletters. We document the occurrence of wake-caused erosion, damage, and safety issues. And this is important as you seek with other lake associations to petition the Maine legislature to establish some wake surfing regulations. So what are our guidelines? Wake surfing activities should be operated at least 500 feet from shorelines, boats that are underway, anchored, moored, and persons in the water. Other boating activities that create large wakes, especially wakeboarding, slow-speed tubing, and touring, should be operated at least 300 feet from the shoreline, docks, and so on. Now let's move on and consider the related problem of propeller wash impact on the lake bottom. It can have a devastating effect by scouring the bottom, resuspending sediment, especially phosphorus, destruction of aquatic vegetation and water critters and their habitats. Now, wake boats have a 20-degree angle on the propeller shaft and another 10 to 15 degrees in a bow-up position, so the thrust of the propeller wash is about 30 degrees down. The velocity of the jet wash is proportional to the propeller pitch and the propeller RPMs, and the jet wash speed decays linearly with distance. This is a simple graphic showing this prop cone wash coming off of a boat moving along on the surface. This graph shows propeller jet speed on the vertical axis and boat speed on the horizontal. The curve shows water jet speed on the lake bottom for a 16-foot, 150 horsepower outboard motor moving at various speeds for various depths of water. The horizontal line shows the water jet speed that will disturb 0.33 millimeter sand on the bottom, a standard used by the study group that did this analysis. Finer grained sand will be disturbed at much lower velocities. Note that the thrust of the outboard motor is straight back as opposed to an inboard that has its propeller shaft angled down, as we just saw. So a major observation here is that the maximum propeller jet speed reaching the bottom occurs at about 9 miles per hour. Faster or slower, and the velocity is much less. Okay, so we're focused on boating activities in shallow water where the boat speed is 6 to 12 miles an hour. And again, it's not just wake boats. Now here's the curve we just saw, and here's the curve that we saw earlier about wave height. And if we superimpose these, it shows that the worst condition happens at the same speed, about 9 miles an hour. So this is sort of a double whammy for this slow speed boating problem. The activities that are associated with these speeds are the wake surfing and slow speed tubing. Wake surfing can have the greatest adverse impact on shoreline docks and other boats, as well as the bottom in shallow water. Now I want to show you a short video. This is a video that I took a few years ago on the lower bay in our lake in 9 feet of water. The test boat was my 18-foot Sea Ray, 130 horsepower stern drive with one person, me, in the boat. Another guy had a Nikon underwater camera on a pole 4 feet off the bottom. He was standing on a pontoon boat. We had a turbidity meter that showed a 10x increase in turbidity. You'll see the propeller start up here and create a lot of bubbles. And this momentarily, you'll see the sediment cloud rising. Here's the sediment cloud rising, and you'll start to see specks of vegetation, and pretty soon a lot of vegetation that's coming into the camera view. And there's the turbidity meter banging around there. So this is what happened with my boat, which is a very small boat in comparison to what the wake boats and other slow speed boating activities can do. Again, slow speed tubing, where grandpa is tubing his 6-year-old granddaughter at a slow speed because the kid is afraid to go faster. And he thinks that doing this 9 mile an hour thing is just fine for the kid, which it is, but it's not fine for the bottom. It just tears the bottom up. And if you have a wake boat with its powerful motors in this kind of shallow water, they will actually plow a furrow in the bottom of the lake. This is the chart we saw before, but now it has the prop RPMs on it as a function of depth for how far this wash cone propagates. So you can see at about 3,500 RPMs, we're down to 18 feet. In addition to that, the prop itself is 30 or so inches below the water surface, so that's even a worse condition. So we had this set of guidelines for the wakes of 500 feet, and now we add further, no such slow speed activity should occur in water less than 20 feet deep due to the propeller wash scouring the bottom. Now this is a flyer that we have created that we pass out at the town office where the boats are registered, at the marina, at our lake patrol, and any forum that we have during the course of the summer to educate people. It's a two-sided waterproof kind of flyer. On the one side, it shows the concerns and the effects and the causes. And the other side, it shows what the guidelines are. And we have a map of our lake, and we have colored in yellow those areas that are preferred to do the large wake activities. And the yellow area is 500 feet off the shore and in water over 20 feet deep. The lake is pretty deep. All that yellow area, it's 155 feet deep at the deepest, and much of that area is 100 feet deep. The lower bay, like I mentioned earlier, is 9 feet deep, and of course there's no yellow down there. Okay, that is the scope of my presentation. I am out of time. I can't do any more, so I'd be happy to answer any questions.
Thank you so much, Don, for your talk. That was really interesting. If anybody has any questions, you can either write them in the chat or feel free to just unmute yourself and ask a question. So there was a question here about mentioning the bottom phosphorus can be disturbed by these boats. Do you have any data to support that?
No, I don't have specific data to support that, but we do know, we have extensive phosphorus data on our lake, and especially the lower bay is prone to getting overloaded with phosphorus, and we have had some minor algae blooms there. The upper part of the lake does not have that problem. But the good thing about the lower bay is that its flush rate is pretty high. It flushes about 4 times a year. The upper bay only flushes once every 3 or 4 years. So the phosphorus problem stays generally under control, mostly because of the flush rate.
We had another question about whether the guidelines have been obeyed, and then I would maybe add on to that, just have they been received well?
Yes, they have. The owner of the marina is a great guy, and he supports our guidelines 100%. And I'd say for the people who live on the lake, they have been very well received. And there are a couple of wake boat owners on the lake, and they're not so much of a problem because they care about the lake. The ones we worry about are the day trippers who bring their boats in for the day and don't have a connection with the lake and therefore don't care that much about it. And that doesn't mean nobody cares, but the incentive to care and abide by the guidelines is much less for people who come in. Now, that's another thing we do. We are very much engaged in preventing milfoil, and we inspect throughout the summer every boat at both of the launch sites. And when these inspectors also encourage and give out these flyers, particularly to boats that have the capability to make big wakes.
Ralph Bednar.
Say again?
I think whoever maybe tried to ask a question, we didn't quite hear you.
I'm sorry, this is Ralph Bednars. I have a question. I'm actually from the state of Michigan, and I'm actually on travel. I'm in Wisconsin today, but I may have missed this because I'm on a phone, but what activity from the standpoint of state regulations of these types of boats are you pursuing in Maine?
The kind of regulations that we would prefer is not regulating the boats, but regulating the activities. We think trying to regulate boats is a dead-end street. But trying to regulate activities, and there's lots of ways you can do that, like time of day, location. We've tried not to regulate horsepower. That's not very doable either on the big lakes. On some of the ponds, we do have horsepower limits, but that's another problem. But we try to have legislation that regulates how and where people can do these big wake activities.
Yeah, I know in Michigan, the boating industry is trying to force or put in regulations for like a 300-foot setback for these types of boats to get them in legislation prior to anything more restrictive. So are you finding that in Maine also?
I don't know about that yet because we haven't gotten that far with it. I just don't know if that will fly in Maine or not, to have our 500-foot standoff for big wake activities. And of course, there's lots of problems, to say if it's 500 feet or any other number, how can most people judge what that distance is and act accordingly? So there's all kinds of problems in trying to enforce, enforcement is another huge issue, because if someone chooses to ignore all of these things, then there's not much you can do about it. The game wardens are few and far between, and they're the only ones that can do any enforcement. So, and I imagine it's the same in Vermont and Michigan and most other states, that the state owns all of the water. None of it's private, and the towns, our township cannot make regulations about the water. Some towns, I know in New Hampshire and in Maine, have made regulations about parking of trailers, and also about charging fees to launch. So there's some things that people have done to try to discourage certain types of boaters, but other kinds, people get wrapped up, like with the bass tournaments, and guys who are using bass boats versus those who are using wake boats. To distinguish between the two in legislation and whatever criteria you want to come up with, it gets pretty difficult.
Yeah, there was a question about if you'd ever considered the use of buoys to mark a 500-foot distance from the shore, to kind of have that visual cue.
No, we have not. That would be a huge undertaking.
Sure.
To do that. Our lake is about 9 miles long, and probably the part it would need buoys is maybe 5 miles long. So it would take a lot of buoys, and the lake is somewhat irregular, so no, we have not considered that. And the water, much of the water is really quite deep too, so it's not a simple buoy. It's a more complex buoy situation.
right? Yeah, that may only work in certain locations. There was another question in the chat about these kinds of issues in Vermont in terms of what our legislature is doing. And Christy Kano shared a link in the chat to legislation was introduced in 2020. Nothing was passed, but a bill was introduced. So if people want to read what it says, you can. There's a link in the chat.
Yeah, I would say again, the study that I mentioned earlier that was done in Georgia is a great study, and it has a lot of information in there about the threat and all aspects of what these wakes and the boats are doing. And I also will say that there's another study that has been completed, but it's not yet released. It's done by done in Minnesota by the Falls River Environmental Group or something like that. It's another major effort. They spent, I don't know, $150,000 to $200,000 on that study. And it will include not only the wakes, but also the bottom impact. So we're anxiously awaiting that study. And the reason it's been delayed is because they have to go through a rigorous peer review so that the lawyers from the boating industry can't pick it apart and say it's not relevant or whatever. But as many may know, the lawyers from the boating industry are quick to jump on any state or municipality that tries to legislate any restrictions on wake boats or wake surfing activities. So there's a lot of money involved here because the boating industry doesn't want to have a reduced market for their boats and so on. So
Great. Well, thank you so much, Don, for your time and information. This is really great. There was one more question, again, just about in Vermont, what kind of rules we have and the types of rules about speed limits and whether or not you can have personal watercraft or different types of recreational uses on specific water bodies. They all live in this use of public water rules document and regulations. So we can share that link. I'll put that link in the chat. But that's the vehicle we have for our rules about different types of boats and speed limits on lakes. So thanks a lot, Don. We actually have on our agenda another little 10-minute break coming up, and we'll have our final round of trivia. So I will share the third round of trivia, and then it is 1:08. So I think if we plan to come back at about 1:20, we will then have our last two presentations of the day and finish up on schedule. Hold on a second. As soon as I can share these trivia questions. All right, let me try this again. All right. So again, just put your answers in the chat box with an email address, and here they are, and we'll see you at about 1:20. Thanks, everyone. All right, welcome back. We have our final two presentations for this afternoon, and then hopefully you all can enjoy this rest of this beautiful day and weekend. First, before we get into the last two presentations, I'm just gonna give the answers to this final trivia round. So Lake Raponda, before it was Lake Raponda, was known as Ray's Pond. And I have a little bit of historical information. I guess there were two brothers, William and Benjamin Ray, who owned the land, and they made it Ray's Pond. And geologists called the large glacial lake that existed 14,000 years ago, Lake Vermont. So we'll be reaching out to folks who won the trivia questions, and we'll get in touch with them about giving them their prizes of maple syrup and the beautiful landscape lake landscaping booklets. All right, so stop sharing here. And next up is Kellie Merrell. It looks like Kellie is getting her presentation up. Kellie has had the privilege of monitoring the status and trends of Vermont's inland lakes for over 20 years. Before she worked for us at the DEC in the Lakes and Ponds program, she worked for EPA in Narragansett, Rhode Island on the Mid-Atlantic Integrated Assessment, which is a precursor to the National Coastal Assessment sampling estuaries from Maine to Virginia. She also worked in environmental consulting in, oh gosh, I don't know how to pronounce that, Kellie. In Massachusetts. Okay. And she received her master's degree from the University of Maryland, where she studied the effects of turbulence intensity on the growth and development of the freshwater plant wild celery. When she's not out sampling Vermont's lakes, she relaxes and gets away from it all with her husband and two dogs, gun-coaling on lakes in Vermont, Maine, New Hampshire, and New York, as well as along the Maine Island Trail in her 19-foot West White Potter trailer sailboat. So welcome, Kellie, and thank you so much for presenting today.
Well, thank you for that introduction. And that was good that it was so long, because it took me that long to figure out how to get my slides up. Okay. So hello, everybody. I'm sorry we're not getting to see you in person. I'm looking forward to hopefully getting to see you next year, or maybe seeing you out while sampling the lakes this summer. Can everybody hear me okay? Or at least one person?
Sounds good, Kellie.
Okay, super. Okay, well, so I don't need to introduce myself, because Laura did a great job doing that, but I do want to just give you a brief overview of what I'm going to be talking about today. So 2 years ago, I spoke to this same group at this seminar and presented evidence that we were losing our oligotrophic lakes. And our oligotrophic lakes are our lowest nutrient lakes in the state, and they are, we've got significantly increasing phosphorus trends. I'm going to touch upon those. Some of you, that'll be a refresher for many of you. But there'll be a little bit of new data in there, some results from our National Lake Assessment. And then I'm going to share with you an approach that would afford increased legal protection for our clearest, lowest nutrient lakes, which will help ensure action actually happens earlier when there is still time to save them and more easily restore them. We heard earlier from Andrew that, restoration efforts can be very expensive. I mean, the laboratory studies and the buoy and the aeration system that's going in on Carmi are all very costly. And if we could nip it in the butt before we get to that point, it would be great. So this audience of all audiences do not need me to tell you that Vermont is stewarding some of the best lakes in the nation. Apologies for the bird that wants to speak to you all. It apparently wasn't chirping just a little while ago, but now it's really singing its heart out. So hopefully you guys could still hear me over that. But so you guys do not need to tell you that we're stewarding some of the best lakes in the nation, but I'm going to do that for you now. Anyway, back in 2007, Neil Kamen participated in the first ever EPA-led National Lake Assessment. And unlike most states, Neil decided to sign Vermont up to participate in what is termed an overdraw level. His foresight led to our being able to directly compare the condition of Vermont's lakes to those of the nation and various the regions around the country, because the methods used were the same and we were able to compare apples to apples. So in both 2007 and 2012 US EPA National Lake Assessments, the Vermont Department of Environmental Conservation participated at the overdraw level, sampling a random draw of about 50 lakes. So except for the upper Midwest, Vermont has a higher proportion of natural lakes than the nation and 8 other ecoregions. In this graph, you'll see that the clear, low nutrient oligotrophic lakes are shown in dark blue. And with the exception of the Western Mountains ecoregion, Vermont has a higher proportion of oligotrophic lakes than any of the ecoregions or the nation. This graph shows proportion of lakes in good, fair, and poor condition for total phosphorus across the 9 ecoregions, the nation, and Vermont. With respect to phosphorus, Vermont has a higher proportion of lakes in good condition than the nation and about half of the ecoregions. Another study comparing water, sorry, the bird is really distracting me. So then we have this other study comparing water clarity across 13,328 lakes and reservoirs across the nation, which found that Vermont had the 4th clearest lakes in the nation. This study looked at Secchi readings to make this determination. And Vermont lakes had a median water clarity of 4 meters, with only Alaska with 5.9 meters, Montana with 4.8 meters, and Maine with 4.6 meters, having clearer lakes than Vermont. In 2016, Stoddard et al. Published findings from EPA's National Aquatic Surveys showing evidence of a continental scale increase in lake and stream phosphorus, suggesting that oligotrophic systems may be disappearing in the United States. You'll see the graph on the right is for the nation's lakes sampled in 2007 and 2012, and later I'll show you the results from Vermont. But that study prompted us to look at our 40 years of phosphorus trends in Vermont's inland lakes. My colleague, Dr. Leslie Matthews, used data from our spring turnover sampling program in a linear mixed effects model, which handles data like ours. On this graph, each vertical line represents a lake. The black dots represent the rate of change for total phosphorus for the lake, and the vertical line represents the 95% confidence interval. The red horizontal line represents no change. When the entire vertical line is above the horizontal red line, that represents lakes that are significantly increasing in total phosphorus, while below the line represent lakes that have significantly decreased. The lines are color-coded according to their trophic condition in the 1980s. Blue is for oligotrophic, green for mesotrophic or moderate nutrient lakes, and red for eutrophic or highest nutrient lakes. We estimated that almost all of the oligotrophic lakes in Vermont have increased in total phosphorus over the last 40 years, as well as many of the mesotrophic lakes. On the other hand, all but one of the oligotrophic lakes had, I'm sorry, on the other hand, all but one of the high nutrient eutrophic lakes have stable or already decreasing phosphorus trends, which you see on the box in blue on the left. Leslie then took a look at our summer volunteer lay monitoring data, which we didn't have it going back as far and for as many lakes, but for the lakes that we had, she found the same results for the oligotrophic lakes in this data set as well. All 9 of the oligotrophic lakes have significantly increasing phosphorus trends. So let's look at the results from the 2007 and 2012 National Lake Assessment, a completely different way of measuring change in total phosphorus levels in our lakes. And it uses a probabilistic and random draw approach, so you can say something about the entire population of the lakes in the state, not the ones that you just happen to be monitoring because you had a citizen lay monitor on them. In this figure, the plot on the left shows the percentage of lakes in poor, fair, or good condition for total phosphorus in 2007 and 2012. The plot on the right shows the change in the percentage of lakes in each condition, and along with the confidence interval for that change. Results are significant when the confidence interval for the change does not cross zero, represented by the black vertical line. In contrast to the results we saw from our long-term study, the percentage of lakes with higher phosphorus, eutrophic lakes, actually increased significantly over this 5-year timeframe. We also found that the percentage of lakes in good condition for total phosphorus, which includes our oligotrophic lakes, decreased significantly from 2007 to 2012 surveys. This result corroborates the results from our long-term spring and summer data sets, as well as the results from the Stoddard paper in 2016 for the nation. Vermont's phosphorus results appear to also exactly parallel the NLA results for the northern Appalachian ecoregion. The region saw a significant increase in the percentage of lakes in the poorest condition and also a significant decrease in lakes in the least disturbed or good condition for phosphorus. In 2007, half of the nation's lakes were eutrophic or hypereutrophic. We haven't even talked about hypereutrophic because it's not really something you see in Vermont, where it is more common across the country and actually becoming one of the more dominant types of lakes. And that is really, really nutrient enriched. So they're very pea soup or very brown water, which is the term. And the term is hypereutrophic is what we use to talk about those lakes. So 10 years later, preliminary results from the 2017 National Lake Assessment find that that proportion of eutrophic and hypereutrophic lakes has risen from 50% to 2/3%, with only 10% of the nation's lakes remaining oligotrophic. So now what? Well, before we get to that, total phosphorus is increasing on our lowest nutrient oligotrophic lakes. We know this from 3 different data sources collected in 3 different ways. Vermont DEC's long-term spring turnover data set, Vermont DEC's summer lay monitoring data set, and now the National Lake Assessment's probabilistic study results from the random sample of lakes sampled in 2007 and 2012. Vermont's phosphorus results appear to exactly parallel the NLA results for the Northern Appalachian region and from the Stoddard et al. 2006 paper for the nation. So now what do? The purpose of the Clean Water Act is to maintain and restore the physical, chemical, and biological integrity of the nation's lakes. As we approach the 50th anniversary of the Clean Water Act next year, we need to reflect on how far we have come with the restoration aspect of the Clean Water Act. We no longer have rivers lighting on fire. And in Vermont, phosphorus trends on our 3 inland lakes that have been listed as impaired and that have approved TMDLs have stable or significantly decreasing phosphorus trends, shown here in spring and summer trend data in the red boxes. So this is true for lakes Memphremagog, Lake Carmi, and Tickle Naked Pond, which, as Andrew mentioned earlier, was recently taken off of the impaired waters list. That's a 100% success rate in stabilizing or reducing phosphorus in all the inland lakes that were listed as impaired and have approved TMDLs. So next year, we have a lot to celebrate. But the maintain aspect of the Clean Water Act has taken a back seat to the restore part. And we are seeing the toll that focusing so much of our attention on our highest nutrient lakes has taken on our oligotrophic lakes at the state, regional, and national levels. So what tools are available? As was mentioned by Ben Copans, Vermont has a set of nutrient criteria in its water quality standards. These criteria were built by taking user perception surveys taken by our volunteer lay monitors while they were out taking their weekly SECI, chlorophyll A, and total phosphorus readings. Eric Smeltzer and Neil Kamen used this data set from Vermont's inland lakes to set nutrient criteria. This was modeled after the approach used to set the thresholds for Lake Champlain total phosphorus. They determined that at a minimum, inland lakes need to keep their total phosphorus levels below 18 micrograms per liter and their water transparency or Secchi readings greater than 2.6 meters, and chlorophyll A, a measure of algae biomass in the water column, to less than 7 micrograms per liter. Lakes where these thresholds are not met were determined to not meet their aesthetics requirement in the standards. Now, aesthetics is a use that is legally protected by the Clean Water Act. There are currently 4 lakes in the state listed as impaired for phosphorus. They are, well, actually, there's a couple more. There's a total of 6. They are Lake Champlain, Lake Carmi, Shelburne Pond, and Lake Memphremagog, Walker Pond, and Mud Pond in Craftsbury. They are considered to not be meeting the aesthetic use requirement. The nutrient criteria were set up not to be one-size-fits-all approach. It sets the minimum threshold for lakes, class B2 lakes. So no lakes in the state can have water quality lower than that floor, and all lakes are legally protected to that level. However, recognizing that there are lakes in the state for which that bar would be too low, the nutrient criteria have 3 additional classes of water. Class A2, which are lakes that serve as drinking water sources and hence need to meet higher water quality standards, and what is termed Class B1 lakes. And for lakes with low nutrients and really clear waters, there's the Class A1 lake. So here's a way to look at all of this that I think will help illustrate why we'd want to upward reclassify lakes currently meeting Class A1 and Class B1 nutrient criteria and hold them to those higher standards. In 1993, a paper came out by Carnes et al., which had this original figure in it, which has any ecosystem attribute on the y-axis. In our case, that's total phosphorus, and then chronological time on the x-axis. Here we see the minimum acceptable state, which currently is set the same for most every lake in the state. The state below which we will not let any lake in the state fall, and that's the 18 micrograms per liter. Earlier, you heard Andrew refer to the minimum that was set by the TMDL for Lake Carmi, and that's 22 micrograms per liter. Then there's the maximum achievable state for a lake, which is going to be different for every lake. And finally, we have the actual recorded condition of the lake. This data is from Caspian Lake, and this photo is actually taken from the sunken island where someone put a little mini lighthouse out on it on Caspian Lake. So roughly 30 years ago, the summer mean total phosphorus concentration in Lake Caspian was 5 micrograms per liter. Is this what Carnes et al. Would term the maximum achievable state for Caspian Lake? The current minimum acceptable state to protect aesthetic use on most lakes in the state is 18 micrograms per liter, over 3 times greater than the historic state of 5 micrograms per liter measured on Caspian Lake 30 years ago. Using the current assessment and listing methodology, the mean summer total phosphorus value for the last 5 years on Caspian Lake is 11 micrograms per liter. That's more than twice what the summer total phosphorus mean was 30 years ago, and still nowhere near the minimum acceptable total phosphorus nutrient criteria standard of 18 micrograms per liter. We see from the Vermont Lake scorecard that while the last 5-year mean TP is 11 micrograms per liter, the overall trajectory of the phosphorus levels in both the spring and summer are increasing. So at the moment, we are waiting until this lake hits 18 micrograms per liter to list Caspian as impaired for phosphorus. At the moment, action in the form of listing it as impaired for aesthetics or phosphorus won't happen until degradation is so far gone that restoration is likely no longer possible, at least not with interventions in the watershed, along the lake shore, in the lake itself, that would be very expensive and likely very unpopular. At the current rate of increase, we might have to wait 30 years before we trigger legal action in the form of listing it as impaired. Whereas if Caspian Lake was reclassified to an A1 lake for nutrient criteria, then we'd be able to act sooner. It would be listed as impaired when it hit 12 micrograms per liter, which is still well below what it was 30 years ago and what it might be considered as its maximum achievable state for this lake of 5 micrograms per liter. But legal action would happen sooner, triggering requirements to act while there is still time to turn the trends around. In 1995, Dr. Daniel Pauly coined the phrase shifting baseline syndrome, where he put some good thing on the y-axis, like water quality, and then time on the x-axis. Now, each generation comes in somewhere on the curve, and depending on where they come in, there begins their baseline for change. The result is that standards are lowered with every generation. On Lake Caspian, for instance, total phosphorus levels were 5 micrograms per liter 30 years ago. They are now twice that, and we need to wait until they are 3 times that to list Caspian as impaired for total phosphorus. If we reclassified it to A1, we'll only need to wait until it hits 12 micrograms per liter, which is still over 2 times what it was 40 years ago, but because we'd be using current condition to set the baseline for the future. But to me, that makes more sense as the minimum acceptable condition for Caspian than the current 18 micrograms per liter. Now, you'll recall that with only the exception of the Western Mountains ecoregion, Vermont has a higher proportion of oligotrophic lakes than any of the ecoregions of the nation. So with respect to the shifting baseline syndrome, the rest of the nation is starting off with lower expectation than Vermont is. But regardless, we too are at the mercy of the shifting baseline syndrome. We want to bend the trend or at least flatten the curve like we have done for Vermont's inland lakes currently listed or recently delisted as impaired for aesthetics, Lake Carmi, Lake Memphremagog, and Tickle Naked Pond. So what does reclassifying A1 get you? Well, while reclassification does not guarantee that the total phosphorus levels will not be exceeded, they do put into place a mechanism for action sooner, when more likelihood of restoration success could be achieved at a much lower cost. Reclassification gets Caspian the tool of legal requirements that come with listing a water as impaired, and in particular helps make funds available sooner for restoration work. This increased protection is afforded the lake even if no other legal lake protections are afforded the lake. To understand what the management implications would be with upward reclassification, reclassifying a lake to A1, we could look to what happens when we similarly legally list a lake as impaired. Earlier today, we heard from Ben Kopens about lakes listed as impaired. And when listing a lake as impaired, we list the lake based on the evidence that the lake is failing our water quality standards. We don't articulate what will and won't be allowed activities in the watershed. That is not germane to the finding that the lake is not meeting the water quality standards. The listing then sets in place the process for which a TMDL, a total maximum daily load plan, is to be developed for the lake and tailored to its unique lake characteristics and sources of phosphorus. Because the Lake Carmi is not Lake Champlain, which is not Memphremagog, which is not Tickle Naked, we don't set management implications across the board a priori before we list a lake as impaired, which makes complete sense because the phosphorus abatement plan for our impaired lakes needs to be tailored to each lake individually if restoration is going to succeed. Similarly, Willoughby is not Raponda, which is not Maidstone, which is not Caspian. So one size fits all does not work for those as we list them as not meeting aesthetic criteria, nor will it work for lakes we list as meeting the A1 nutrient criteria. So what's the plan? So we're suggesting we should try a similar approach to reclassification that we do to listing. We list lakes that meet the nutrient criteria for A1 as A1. Then let's have this set in motion the requirement that a protection plan be tailored to the lake similar to our TMDLs and lake watershed action plans. What this does for our high quality oligotrophic lakes that is not already possible is that it's the primary benefit is that restoration can happen when and if the water quality drops below the minimum acceptable state for an A1 lake, which is currently 12 micrograms per liter, and we won't have to wait until it falls to the minimum acceptable state for our B2 waters, which is 18 micrograms per liter. But before that happens and after it is listed as an A1, a lake protection plan could be developed similar to TMDL plans on our impaired lakes and lake watershed action plans. Ultimately, an A1 designation would officially be recognizing and calling out the high quality nature of the lake. And as such, one could use that as an argument to garner funding from Act 76 which, as Phoblev heard from Agency Natural Resources Secretary Moore at the seminar in 2019, $3 to $5 million each year can be applied to high quality waters. The same argument could be made then competing for funding for the Clean Water Initiative and Lake Champlain Basin Program funding. Here's an example of the steps that might make up a protection plan. First, we want to determine where the phosphorus is coming from, and maybe we'd want to figure out a form of total maximum daily load for the lake. Once we have a good handle on where the phosphorus sources are likely coming from, we can develop remedial intervention options and then implement the preferred ones. Finally, we'd need to monitor for compliance and effectiveness of the remediation to see if it's actually working. The hunt for phosphorus sources in this watershed, that being Carmise, is going to be multifaceted. Caspian's watershed scores poor for human disturbance. It also gets a poor score for shoreland condition, and 20% of its tributary buffers is classified as agriculture, and 10% of its lakeshore is impervious surfaces. So the protection plan is going to have a lot of sectors to cover to find primary sources of phosphorus to Caspian. Ultimately, a protection plan for Caspian might enhance support for lake-wise on the lake, provide incentives to upgrade septic systems, and potentially ramp up tools in the Shoreland Protection Act that will result in reductions in current runoff as part of any permit requirements for redevelopment that could come in. Caspian happens to be a delegated town, so this will need to happen at the local permitting level. Plus, we need to work on reducing runoff to tributaries from roads, agriculture, forestry, and development in this large watershed. All of these efforts could be done at the grassroots level now with a lot of community organizing, but accessing funding either through Act 76 for high quality waters or through listing when the nutrient criteria are exceeded will help these efforts succeed. But ultimately, none of these efforts are going to succeed without the interest in protecting and restoring the lake at the local level. In closing, we know from mapping we have done that Vermont's lake shores are some of the most densely developed areas of the state, and the applications to build or expand existing camps and with impervious surface and clearing of vegetation are hitting record highs. This is a graph depicting the amount of permit applications the Vermont Department of Environmental Conservation has received each month since the Shoreland Protection Act was passed in 2014. 2020 was a record year with 302 applications. And you'll see this year's applications for building and rebuilding along Vermont lake shores depicted in yellow. March and April set new records for applications. So we are on track to beat last year's record. Now, while the Shoreland Protection Act is helping to reduce the impact this new and expanded development will have on our lakes, they will still impact our lakes. With so many people investing and invested in lakeshore property in the state, it seems imperative we find a way to better protect these investments by matching our nutrient criteria standards on them to our real minimum acceptable state for them. To learn more about how these and existing property owners can adopt more lake-friendly practices, I encourage you all to stay tuned for our next and final speaker of the day, my colleague, Amy Picotte. Thank you all for listening.
Thanks, Kellie.
Oh, good. You're still there.
Nice job. Thank you, Kellie.
There is a question in the chat. I'm very echoey, so.
I can hear you pretty good.
Okay. The question is, you use the term restoration. Do you mean protection? Are you holding the line on total phosphorus at 11 micrograms per liter, or are you trying to get it back to 5?
So the reason I use the words restoration, and actually the Clean Water Act uses the word maintain in the goal. The overall goal of the Clean Water Act is to maintain and restore the chemical, physical, and biological integrity of the nation's lakes. Hence the use of restoration and maintenance. But also, some people use the term protection as a substitute for the word maintaining. And so it's it's sort of interesting. This gets at really an interesting point because I never really thought of the nutrient criteria. Nutrient criteria is something that EPA has been really wanting states to adopt. And they came to us from sort of the model of Chesapeake Bay, where they set sort of thresholds for nutrients there, and they wanted to sort of expand that, I think, to freshwaters, and because it was working well in the Chesapeake Bay area. And Vermont is one of the few states that has adopted it. And I've always sort of thought of nutrient criteria as really setting the, the floor, that area where you're just not going to let a lake fall below it. But in this case, you can look at it this way because we actually have higher floors, and it will, to some extent, is a form of protection. If you don't let it, if you raise that floor, you actually reduce, the time you have to wait until you actually would be sort of legally forced to act. And so that's in my, view, is the way in which this is both a form of protection as well, and it gets you to a point when that you can, if you exceed that floor, then you can start the restoration process sooner rather than waiting until you're at that really the floor that, most lakes in the state, that 18 or many lakes in the state, 18 micrograms per liter will be a good threshold for. And like we heard earlier, Tickle Naked's threshold is actually 22 micrograms per liter. And that came out of the, the work that was put into the total maximum daily load to figure out what that actually was for Carmi. I don't know if I actually answered the question. Sorry. But feel free, whoever it was who asked it, to, email me or call me if you want me to clarify that more. Or if Oliver wants to save me.
Hey, Kel, are you still sharing your screen?
No,
Okay.
I don't think so.
There is one other question, and this is also a great segue into Amy's talk. But this question says, you imply that lakeshore development is the cause of increasing nutrient levels in Vermont's clean lakes. Is this a dominant cause? And is the cause of the general increasing trend really understood?
So no, the cause is not understood. We're still, Mindy Morales at UVM is searching for funding to help us answer this question. She's applied for a couple of grants. We've gone in with her on those. We have some work we're doing with looking at Maine's lakes that are not increasing because their oligotrophic lakes are not increasing, to see if maybe their 40 years of protecting their vegetative buffers along their streams and along their lakeshore is, is the potential cause for them not to have increasing trends on their oligotrophic lakes, and for us to have those trends. And what was the rest of that question? I'm sorry.
Well, so that lakeshore development.
Yeah, no, each lake is, as I mentioned earlier, each lake is different. So I showed you some sort of like, we now have this high resolution mapping. Alan Dowie from the A&Rs, well, actually he's with Digital Services now, has been doing and creating, and he's working on creating it for all of the lakes 10 acres or greater. And it's using newly released high resolution, down to ½ meter resolution, where we can actually look at the watershed scale, at the tributary scale, at the shoreland scale, within 100 foot of a buffer, to see what are the major stressors or human disturbances in that area. And so we've got those maps on these oligotrophic lakes. And for Maidstone, there's no agriculture in that watershed, zilch, and there is some forestry in that watershed. But then, when you look at the land use, there is a large amount of impervious area around Maidstone that is the primary sort of potential smoking gun. Again, we haven't we haven't done a protection plan for that lake. We haven't put like a TMDL effort into that lake like we've done on Carmi or on Memphremagog or Lake Champlain. So we don't really know that, but we can use so the short answer to your question is that on some lakes like Maidstone, the development along the shoreline is going to be probably the source you're going to want to look most closely at. They have maybe 2 tributaries on that lake. They're very, very tiny little tributaries. And so just sort of honing in on that. But on Caspian, it's going to be not just the shoreline, but you got to look at that ag, that's especially the ag that's within 100-foot buffer of the tributaries that are draining into it. You also have roads, and so there's a lot of different things to look at. And I'm not pointing the finger at lakeshore development for every lake in the state, but it is, it's part of the whole, it's like everybody's in. This was something when the Clean Water Act, Act 76 for Vermont was passed, it was everybody's in, whether we're not going to, it's the farmers are in this, the lows and the developments and the impervious surfaces are in this, anything that contributes phosphorus to Lake Champlain is going to be in the targeted range for trying to figure out how to reduce its impacts and reduce that phosphorus.
Great. Thanks, Kelly.
Thanks.
I'm going to go ahead and introduce Amy. As the Vermont Shoreland Specialist, she provides technical assistance to shoreland owners for protecting water quality, wildlife, and property. She's written over 25 fact sheets on lake-friendly practices and most recently has developed a draft of the Emerging Vermont Bioengineering Manual, which features ecological methods, case studies, and native plants for stabilizing lake shores. Prior to overseeing the Lake-Wise Shoreland Program, Amy monitored lakes for 20 years as coordinator of the Lay Monitoring Program. Her undergraduate degree is in plant and soil science, and she has a master's degree in science education. She's also a mom to a son and daughter who, among many things, remind her every day why natural resources protection is essential for today and future generations. So this is our last talk of the day, and we're happy to have Amy talk to us about some solutions to some of these phosphorus issues that we've been talking about today. So thanks, Amy.
Well, thank you, Laura. Can you see my screen? I just want to make sure.
Yep, looks good.
Oh, it looks okay. Okay, well, thanks again, and thank you to the Federation of Vermont Lakes and Ponds for all the work that went into offering this year's lake seminar. At this point, I recognize that I'm the only thing. This is the last presentation that's probably between now and when you can start your weekend. So I'll try to stay right on schedule here as I present the Shorelands Problems and Solutions as the last presentation to the 2021 Vermont Lake Seminar. My presentation is going to expand on Kelly's last point, which was ultimately about partnerships to protect the lakes. And as soon as I can advance this. Okay, here we go. So throughout today, we've heard a lot about the science on how different land uses impact water quality and wildlife habitat. This photo from Lake Champlain's Isle Lamont during the high waters in 2011 clearly shows the sediment runoff exclusively from shorelands, as there's no tributary nearby. Our challenge is how to prevent scenes like this shoreland runoff from ever occurring again. So the challenge is how to go from the highest residential density in Vermont, 2.5 times higher than downtown Burlington or Rutland or anywhere else in the state, along our shorelands, with excessive clearing and not sort of more the conventional style of development, which wasn't known for lake-friendly practices. So how do we go from this high residential density to restoring our shorelands so they're not polluting and degrading our lake ecosystems? But adding to the challenge is that about 85% of Vermont is owned privately, and more than 85% is owned privately along our shorelands. So we've heard a little bit about the 2014 Shoreland Protection Act that was passed, and for the first time gave statewide review to development within 250 feet of the mean water level. For most projects, that increase the impervious surface area or clear native vegetation, a permit is likely needed. And a permit specialist, like Laura Dugalecki, should be contacted before any project starts. This law also mandated that a voluntary shoreline erosion control training be offered annually for contractors. And as a reminder, we have 800 lakes in Vermont, over 1,400 miles of shoreline, with at least 85% in private ownership. The Natural Shoreline Erosion Control Certification trainings brings both the shoreline owner and local contractors, from landscapers to site workers, to the same page for understanding the principles and practices of lake-friendly development. The Natural Shoreline Erosion Control Certification workshops are offered as in-classroom trainings annually in November, and to date, more than 500 contractors have been trained in shoreline best management practices, including introducing them to bioengineering techniques. And more than 50 contractors have received hands-on training through the field installation training events. So bioengineering practices are also referred to as living shoreline projects or nature-based solutions. Oh, I thought I heard an echo. These methods are considered softscape engineering techniques used to stabilize slopes and shorelands with native plants, biodegradable products, and other natural materials. The bioengineering methods really protect property from waves and erosion while filtering stormwater to the lake and restoring wildlife habitat. So it's really important to know the options for wildlife-friendly erosion control products. And we point this out during those trainings, as well as cover the science and the engineering of shoreline BMPs. In this slide here, we want to get away from erosion control blankets that use the synthetic netting that can harm wildlife. And at the 2020, last fall's annual training for the Natural Shoreline Erosion Control Certification Program, we were really lucky to have this group of students they're from the State University of New York, and they've earned an award designing an erosion control blanket called the InstaBuff. And they presented this at our workshop. And in doing so, they made contact with E.J. Prescott, which is a huge supplier of erosion control materials. And as they presented last fall, their product has all sorts of benefits. It's easy to use, especially for those that don't know a lot about gardening. It's instantly effective and easy in that it plants an instant buffer, which can be used right along riparian stream areas and lakes. And it also they've calculated out the phosphorus reduction based on this product. But I think the best news that comes is that they are in discussions now with E.J. Prescott in trying to develop and market this product. So hopefully we'll have that available soon. So for the next few slides, I wanted to share a bunch of examples of bioengineering projects in Vermont and ones that we continue to go back and assess today. This was one of our first projects in 2015. So these are fairly new techniques, and some of you have heard me present on these before, but this was Lake Iroquois on Williston, Vermont, with a lake fish and wildlife access area that had been sloughing off. There was a lot of erosion along the bank. And we used a simple method with a fiber core roll and slope back and replanted. And it's just held so well against the ice and the wind. Another method we have been using are these encapsulated soil lifts. And this was a more challenging site. It was 300 feet long. It ranged from a 12-foot drop to a 5-foot drop. And these are sort of mini terraces that you build out. But again, this is held up as well and has stabilized the bank between the road and the lake and offers a filtration system for the road runoff. I like to show this project. It's one of now almost a dozen where we've trained a contractor through the Natural Shoreline Erosion Control certification program. And they now have reached out and worked with a private shoreline owner. And in this case, they used the fiber core roll method, slope back and planted. And this was done by Nectar Design and also with the Essex Natural Resource District on Maidstone. And even last year during COVID, we did get 4 projects in place, which was really, really hard. A lot of these materials come from Sri Lanka. So, but we pulled it off. This is a project on North Hero, and the Federation of Vermont Lakes and Ponds helped buy some. Don Weaver was involved with coordinating, help buy some of the plants for this project. And again, we matched a private contractor up with a private shoreline owner and using these restorative practices, these softscape engineering practices. So this is a real area of concern. It's growing. What do you do with these beautiful public beach access areas that people have grown to expect? They're sort of artificial beaches. Sand is brought in, there's not new beaches being made, but how do you maintain these existing beaches that have once cleared away the natural vegetation and put in sand? Sand is really unstable and it moves easily. It washes and fills into the lake. And you can see from the Google Earth imagery there, you can see how the sand has now moved down beyond the beach and is smothering the aquatic habitat along that whole shore. So this is years and years of putting sand down in these areas. So it is a problem for aquatic habitat. Sand doesn't necessarily carry phosphorus with it, but it does destroy the littoral habitat. So we've come up with some solutions, and down below on this slide, to delineate the border along the beaches can help stabilize the sand and minimize the erosive forces that wash it into the lake. And we did a project up at Shadow Lake years ago up at Glover with Chrissy Kano, and we had to really manage the upland sources of runoff, and we put a water bar in feeding out to a rain garden to protect their beach area there. Here's another look at a project down at Lake Rapunda, where again, we've recreated a toe along that bank, which was sloughing off, and we used fiber core rolls, put erosion control blanket, and then slope back and planted. And it sort of sets a new expectation for when you arrive at these public access areas. You might have to walk through plants and vegetation, and over time, there would be a shade tree for grandparents. There might even be a tree for a rope swing and hammocks at some point. So we're slowly trying to work with a new expectation for these public beach areas while minimizing the sand from eroding into the lake. Another project on a beach was Camp Moriarty last fall up at Salem Lake, and that's holding really well. This is the town beach on Salem Lake at Derby, and just giving you some more ideas of how these bioengineering practices can really be restorative for reestablishing living shorelands. So we are having this bioengineering manual. It's coming out this fall. All these methods, it's really a recipe for contractors on how you install these. And we haven't had that before. So I'm very excited to get that available and online soon. And so all these demonstration projects help influence social norms, which is what the Lakewise program is based on. We have the science and we have the engineering designs for managing stormwater and protecting water quality, wildlife, and property. But none of these resources provide guidance on how to get people to implement these practices in around their lakes. The Lakewise program, as most of you know, is a shoreline initiative that awards lake-friendly shoreline property. Lakewise is based on social science research that shows people are most influenced by their neighbors. The Lakewise Award sign showcases lake-friendly properties and is meant to inspire others along the shore to make improvements so they can too earn the award and help protect their lake. At Seymour Lake, shoreline owners became aware of their role as part of the solution for a clean lake, and from their actions along the shore, what had been an increasing phosphorus trend in the lake has now been stabilized. This is an amazing outcome of positive partnering to protect the lake. And the lake leaders, Peggy Barter, Rhonda Shippey, Tracy Shadday, and their whole team of lake stewards deserve full credit for this success story. If you can see me, my backdrop here is this picture. And I wanted to reference this because it is another success story using vegetation to restore a riparian area. And in this case, it's along the Detroit River. But when we look at what's going on elsewhere outside of Vermont, we get inspired by these events. And this Detroit River once caught fire. And it was named in 2021 as the best river walk by USA Today. And this river had a lot of industrial waste and was armored for 14 miles long with car factory sprawl. It's taken over a decade to de-armor the river frontage using bioengineering methods and to reestablish a living shoreline. And this project really stands out to me for 3 reasons. First, it showcases one of the first examples of bioengineering. It has helped advance the environmental justice movement, which is an effort to clean up and restore healthy environments, especially in impoverished communities, which exist closest to polluted, degraded areas. And thirdly, during COVID, this river frontage became a refuge for many, with an increased use of 30% by the Detroit population. So people thrive in these natural settings. They depend on nature. And this is a wonderful project that shows that we can use these methods to restore and protect our waterways, as well as help our own sense of wellness. So social science is essential to understanding how shorelands owners make decisions on their property, including more natural shoreline vegetation, which we know plays a key role in keeping lakes and shoreline habitats healthy. Social sciences show people, whoops, that mess. Social sciences show how and why people act. And we know that people are influenced most by what they see and hear from their neighbors. We also know there's a lot of research on social sciences, and the University of Wisconsin has put out a really nice summary of social sciences for shorelands and what gets shoreline owners to plant more vegetation along the shore. It's a great list of resources and publications. But basically they've sort of narrowed it down that prescriptive messages are very important, when you're trying to get people to take action, and messages that include the benefits to people. So these are examples. Your neighbors are protecting your lake. Are you? If you like songbirds, then plant, and you have to be specific here, an oak, cherry, or viburnum native plant, for example. Or plant pollinator species gardens for your own enjoyment of wildlife. But one of my all-time favorite scientists, and I love it when some of you send me links to some upcoming talks by Dr. Douglas Ptolemy. He's out of the University of Delaware, and honestly, he's really like the terrestrial scientist's equivalent to the Jacques Cousteau. He says, restrict turf to paths that guide pedestrians through your landscape. So it's an action-oriented statement, and he has earned a lot of followers, and with his science, and the main message is to minimize your lawn. So a message that I find works well with people is about protecting property. Like, let nature protect your property so you can relax, which I'm hoping all of you will do this weekend, especially those that are just returning to the lakes around Vermont this week. So I'm going to end my presentation with a tribute to Marty Illick from the Lewis Creek Association. Some of you may know Marty, probably have worked with Marty over the years. She died in a tragic boat accident this spring with her husband on Lewis Creek, but she spent over 25 years as the executive director of the Lewis Creek Association, and I'd like to end with a quote from her, which is, working on the ground in our local watershed communities, we can get a whole lot done. And I really believe that. And every day I get inspired by stories about Detroit riverfront, working with people like Marty, working with people like all of you. And I wish you the best of weekends. And thank you for being part of the solution for clean lakes, because as everything we've heard today, it really does come down to that ownership of private property and how we can influence, inspire, work with each other and others to adopt these lake-friendly practices, whether it's bioengineering or whether it's a water bar in your driveway or infiltration steps. But thanks for making the difference on your lake. And I am glad we're getting out on time today. So, and thank you, FOVLAP and Laura, for all the work you've done with the 2021 Lake Seminar.
Thanks, Amy. That was a great tone to end this on, and an important message for people to take back to their lakes. I'll see if there's any questions that come in over the chat, or feel free to chime in if you have any questions for Amy. Well, you know, as has been mentioned, I think we all miss getting to chat with each other over an in-person lunch and see each other's faces, but hopefully next year we can join in person again. But this has been really great, such a wonderful day of talks, and I just want to thank the events committee for all their hard work in getting together this really great agenda, and all the speakers who took time out of their day to present. So does anybody have any thoughts or comments? We will be, let's see, Jackie, is the link to the survey, can that be put into the chat?
Yeah, David may have it.
Okay, if not, we will send it out.
I definitely have it. I just have to find it.
Yeah.
But we're planning on sending it out to all the attendees within the next couple of days as well. But I'll look for it right now.
Okay, yeah, me too.
Yeah.
Okay, I think I found it. Great. So if you all can take just a few minutes to fill out this survey, that's really helpful for us. And so I put it in the chat, but if anybody else, we'll send it over email. And thanks so much, everyone.
Yeah, thank you, Laura, Jackie, and the whole event team from FOBLAP.
Thank you. This is wonderful.
Yeah, really good. Stay well, everybody.
Thanks.
Thank you. I really appreciate your efforts. Thank you very much, Jackie and all, and it was a great presentation.
Jackie, so I kept a little running list of some of the questions that came up that we might want to follow up with folks on, and I'm happy to reach out to speakers to get the right answers. And then I've got some links and to handouts and things. So I'll just send it all to the events committee, and we can, whoever sends out the email with the link to the survey can maybe include that as well. Oh, you're on mute.
That sounds like a good idea. I think having it all in one place, like with the committee, then we can decide how we want to do that. I can't remember, without looking at my notes, what our plan was. I know that it was going to be sent out, I think by David, but whether we want, whether Bruce has a more accurate email list. I mean, he sent us the list that he had, but it didn't have everybody on it, because I think other people shared the link with people that hadn't registered. So I'm not exactly sure. Maybe we should at least email about the